Assalamu alaikum, my dear students. I hope all of you are fine and having good health. In our today's video, we are going to discuss about the molecular formula. So, in this topic, we will discuss about that formula, that how we can calculate this formula, and basically what formula is going to be used for its identification. So, the first one we have its definition. Basically, this formula shows us the actual number of atoms of each element that is present in the molecule of a compound. So here, for example, we have a molecule like glucose. Its molecular formula is C6H12O6. Over there, carbon atoms 6, hydrogen is 12, and oxygen is 6. So it is going to tell us the actual number of atoms that are present in the molecular formula. For example, we have over there butane. It is having 4 carbon atoms and 10 hydrogen atoms. So actual number of carbon and hydrogen atom, the ratio over there is 4 ratio 10. Next we have octane. The word octa means 8. So in this compound we have 8 carbon atoms and 18 hydrogen atoms. So the ratio over there we have 8 ratio 18. So the compound, if is there any compound and we have its formula, and that formula tells us the total number of atoms or the actual number of atoms, total number of atoms that are present in it. This formula we called it as the molecular formula. Next we have the calculation of the molecular formula, that how we can calculate the molecular formula. Basically for the calculation of the molecular formula, there we have a formula. We can calculate the molecular formula from the empirical formula. So for the calculation of the molecular formula, we need to know the empirical formula, because the formula for molecular formula we have, it is N multiplied by empirical formula. Now what is the N? It can be any integer that starts from 1 to so on. So N is the simple integer number, and we have to multiply it with the empirical formula. Now in the previous lesson, we have already learned the method to find the empirical formula. For the empirical formula, we need to know the percentage composition of all the elements. Second step was to find the number of gram atoms. And the third one is to find the simple ratio of atoms or atomic ratios. And then the last one step is to convert it into the whole number if it is in the fraction form. And from the empirical formula, we will be able to know about the molecular formula. So to understand this topic, here we have an example that is very interesting, that how we can find the molecular formula. So in this example, we have the combustion analysis of an organic compound shows that it contains 65.44% carbon, 5.50% hydrogen, and 29.06% oxygen. So here the percentages are different. What is its empirical formula? So first step, we have to find the empirical formula. If the molecular mass of this compound, so molecular mass is given over there, how we can calculate the molecular formula by using this. So the first step is to calculate the number of gram atoms, because we have already its percentage composition. So the number of gram atoms for the first compound, we have number of gram atoms. So number of gram atoms Here we have three carbon, hydrogen, and oxygen. So number of gram atoms of carbon, it is equal to its percentage composition, which is 65.44 divided by its mass number, that is 12 gram per mole. So its number of gram atoms over there we have 5.45 of carbon gram atoms. Next we have number of gram atoms of hydrogen. For this we need to know its percentage, this is which is 5.50 divided by its mass number, which is 1.008 gram per mole, and the answer we have 5.46. This is for hydrogen. And next we have number of gram atoms of oxygen. So the percentage of oxygen we have 29.06 divided by 16 gram per mole, and the answer we have 1.82. So here we have the gram atoms of carbon, hydrogen, and oxygen. After that, the next step we have to find its molar ratios. So to find the molar ratios, we have to do the comparison of its different ratio. As the molar ratio we can find carbon ratio, hydrogen to ratio, we have the ratio of oxygen. So here the carbon, it is present in 5.45 ratio, hydrogen is 5.46, and oxygen we have 1.82. Now we have to simply divide it with the smallest number, and the smallest number of oxygen is 1.82 divided by 1.82 divided by hydrogen with this, and also oxygen with this. So the ratio that we gain, it is 3 ratio 3 ratio 1. So this is the molar ratio, and from here we have the molecular formula C3, hydrogen 3, and oxygen 1. So this is the simple empirical formula for the compound. So we have find the empirical formula. The next step is to find the molecular formula. So to find the molecular formula, what we need basically, first we have to calculate the empirical formula mass, or the molar mass of the compound, and it is given in the statement, that is 110.15 gram per mole. So the molar mass of the compound is given. This is its molar mass. Now from the molar mass we will find the number of N. So where N is equal to molar mass of compound divided by the empirical formula mass. Empirical formula mass. So the empirical formula mass, we will find it from there. As there are 3 carbon atoms, 12 multiplied by 3, plus hydrogen is 1, multiply it with 3, and 1 oxygen we have 16. So the answer over there we have, it is 55 gram per mole. Now from 55 gram per mole, this is the empirical formula mass. So we will find the value of N. So to find the value of N over there, molecular mass of compound is 110.15 divided by 55. So the answer we have, it is 2. It's mean the value of N we have 2. Now we will find the molecular formula. So the molecular formula is equal to N multiplied by empirical formula. So here the value of N is 2 and the empirical formula we have it is C3H3O. The molecular formula will be we have to multiply the 2 with the numbers. So we will gain C6H6 and O2. So this is the molecular formula that we gain from the empirical formula. I hope you guys understand about this, that how we can practice that or how we can find that. And the next session we will discuss about the concept of mole. For that time, you guys have a good day and Allah Hafiz.